All right, we're looking at solving by factoring right now. This is from section 6.2 in your textbook. So a quadratic expression can be solved by factoring. Another word for finding the solution is finding the roots. So what we're going to do, we're going to follow 3 steps every time. So step 1, put the equation into standard form. Okay. And standard form looks like ax squared plus bx plus c equals 0. Okay, so we're going to get into that form. Second, we're going to factor the quadratic expression. And then thirdly, we're going to set both parts of the product equal to 0 and then solve. Okay, so for the first example, and for each of these examples, you've got to be a master of factoring here. So it's a basic skill in order to get into this. So we look at this one right here. We got x squared plus x minus 12. And we have to remember that factoring tree that I've shown in class. So we look at the top and we say, is there a common factor? No, there's nothing common. Is it a bi or a tri? So it's a trinomial. And this one's an easy one because there's no number in front of the x squared term. So we're looking for something that adds to 1 and multiplies to negative 12. You may note, by the way, I skipped step 1 here, put the equation in standard form. That's because it is in the form I want it to be. It's got ax squared plus bx plus c. So I need to come up with 2 numbers that add to 1, multiply to negative 12, and they are 4 and negative 3. So that means factored form is x plus 4, x minus 3. Okay, and it says step 2, set both of the products equal to 0. So we have here that we want to know when does x plus 4 equal 0, and over here we want to know when does x minus 3 equal 0. And these are linear equations that can be solved, so we minus 4 from both sides. We get x equals negative 4, and here we add 3 to both sides. We get x equals 3. So you would know this question is correct by simply plugging in the solution in for your x's. So if you did 3 squared, right, plus 3 minus 12. So 3 squared is 9, and 9 plus 3 is 12, and 12 minus 12 is, boom, 0. It equals 0. So it does exactly what we want it to do. We want to find out a value for x that would solve the solution. It would also work for a negative 4. There's 2 answers. All right, let's look at our next example here. So we need it in standard form. I'm going to move everything to the left here because it will result in positive values rather than bringing it to the other side. So we get 9x squared plus 9 equals, and we have 10 left on the right. I'm going to minus the 10 from both sides. So you get 9x squared minus 1 equals 0. Now I look at my factoring tree and I say, is it a binomial or is it a trinomial? This is a binomial, and it's a difference of 2 square numbers. So 9x squared minus 1 is 3x minus 1, and 3x plus 1, and that equals 0. So we've got this factored down. And just like before, we're going to set both sides of the products equal to 0. So we've got 3x minus 1 equals 0. And we'll do 3x plus 1 equals 0. Again, these are just linear equations that can be solved. So we add 1 to both sides here. We've got 3x equals 1. And then we divide both sides by 3. And we get x equals 1 over 3. Over here, we minus 1 from both sides. So we get 3x equals negative 1. Divide both sides by 3. We get x equals negative 1 over 3. Again, how would you know if your answer is correct? Well, you can plug in 1/3 for each of my x's and make sure that the left side of the equation equals the right side of the equation. That would prove that you got the right answer. All right, next one up. So we want to add, is there a common factor? No. Is it a bi or a trinomial? It's a trinomial. Is it the easy one? No. No. Is it a Perfect square, no. It's the MFFM method. So we do what adds to 5 and multiplies to, remember we do 2 times negative 12, which is negative 24. Two numbers are 8 and negative 3. Okay, so using that MFFM method, we put a 2 here, a 2 there, 8, negative 3. We simplify the top, so we get 1 and 4, 2 and negative 3. So now we have 0 equals x plus 4. This represents x plus 4. This represents 2x minus 3. There we go, it's factored. Now, set both products equal to 0. So x plus 4 equals 0. 2x minus 3 equals 0. We're going to minus 4 from both sides. So we got x equals negative 4. Here we're going to add 3 to both sides first. So we got 2x equals 3. Then we're going to divide by 2 and get x equals 1.5 or 3 over 2. There's our two answers again. All right, our last example. We got 4a squared minus a equals 0. Notice on this one you have a common factor, which is a. It's common to both. And take a out of it, you have 4a minus 1 equals 0. Now this is not a difference of squares. Okay, you can't square root a nicely. But you can actually see this as a product, because what we have right there is an a times 4a minus 1. So we're going to say set this equal to 0, and we're going to set this equal to 0. Okay? So this, I don't have to do anything with it. It's done for me. And this one, we can add 1 to both sides. You get 4a equals 1, divide both sides by 4, and we get a equals 1 over 4, 0.25. Again, you could plug it in to check if your work is correct. At the heart of this whole thing, by the way, I'm not sure I aced explaining this, but the reason why this step works right here, where we set either product equal to 0, is simply that think about what happens when I plug in negative 4 into the equation. If I put negative 4 in there, I get negative 4 plus 4, which is 0. And 0 times whatever that is, it doesn't matter, is 0. So the reason why we're able to do this is simply if we make this equal to 0, then the whole thing equals 0. Or if this equals 0, then again the whole thing equals 0. So all we have to do is set one of the products equal to 0, and we'll get a solution. And why this is different than linear system is that this is quadratic. And so oftentimes there are two places on the graph where the graph equals 0. So this is how we'll use factoring in order to solve a quadratic equation.